Hello, gentlemen. I decided to make a video detailing this process for step number 2, for problem number 2 on the stoichiometry practice problem worksheet. So I'm going to begin with given the following unbalanced equation, P2O3 decomposes into P4 and O2, oxygen gas. My recommendation is that you balance out your atoms that are non-oxygen, carbon, or hydrogen first. So we're gonna let's balance out the phosphorus first. Since we have 4 phosphorus atoms on the right, 2 on the left, we're gonna add a coefficient 2 because this 2 multiplies this phosphorus by 2, making 4 on this side. But this also goes in distributes into the subscript 3 on the oxygen, creating a total of 6 oxygen atoms on the reactant side. We can change that by adding in a coefficient 3 right here. And we do not need to change the P4 coefficient, so we're going to leave that at 1. So that's how we balance out the equation right there. And the rest of the question asks, if we start out with 100.35 grams of P2O3, what mass of P4 do we end up with? What mass of O2 do we end up with? Use correct units and label what the mass of P4 is and what the mass of O2 is. So we're going to do it step by step. Let's begin with solving the mass of P4 we can produce. It tells us that we are given, once again, first thing you should do is write your given, 100.35 grams of P2O3. We know we need to use a conversion factor, and we need to convert from the grams of P2O3 to the grams of P4. But before we do that, we need to take things step by step. If we have the grams of P2O3, we need to solve the moles of P2O3. And we use the molar mass of P2O3 to solve for that. The molar mass of P2O3 is going to be 109.94 grams. We know that by looking at your periodic table, finding the atomic mass of phosphorus, multiplying that by 2 because there are 2 phosphorus, and adding that to the molar mass of 3 oxygen atoms. So 1 oxygen atom is worth 15.999 grams per mole. Multiply that by 3, add all that together, and you should be getting 109.94 grams. And again, if we're given the grams itself should also be on the bottom. 109.4 grams. Sorry, 0.94 grams over 1 mole. And I'm just going to continue the process as well. From there, we convert from the moles of P2O3 to the moles of P4. From that, we use to convert the mole ratio from the balanced chemical equation. In the balanced chemical equation, we use 2 moles of P2O3 to produce 1 mole of P4. Again, what you're solving for goes on top, 1 mole P4 over 2 moles P2O3. And then, but it's asking us to solve the mass of P4 produced. So now we have to look at the molar mass of P4. So you go to the periodic table, find the molar mass of P, which is 30.97. It goes on, but just 30.97 is fine for now. 30.97, multiply that by 4 because there are 4 atoms in P4. And that is going to bring us to 123.895. And since we're eliminating mole, this is for every 1 mole of P4. And it's 123.895 grams per mole of P4. And now, I just want to show you how everything cancels out. This is why I ask you to leave your given alone. Don't put a fraction under the given. Just leave it alone. And then just follow along with the units. The grams cancel out. Let me use it. The grams cancel out. The moles of P2O3 cancel out. And the moles of P4 cancel out. And the only thing we're left with is the grams of P4. So once you manage to get all the conversion factors together, eliminate all the previous units to solve for the new units, you get to you're able to calculate, and this is determined to be 56.5 grams of P4. Okay, 56.5 grams of P4. That is the mass of P4 you can produce from the initial 100.35 grams of P2O3. Okay, but that's just the first answer. That's the first part of the problem. The second part of the problem is asking us to find the mass of oxygen gas, O2, formed from the initial 100.35 grams of P2O3. So I'm going to bring this back down, 100.35 grams of P2O3. It is a very similar process. We know that 1 mole of P2O3 is worth 109.94 grams of P2O3. But now instead of going from the moles of P2O3, we need to find the moles of oxygen, and from there the grams of oxygen. And here's where we use the mole ratio conversion factor. We're trying to eliminate P2O3, so on the bottom we're going to put the 2 moles of P2O3, and we get that again from the balanced chemical equation. That's why balancing chemical equations are so important. On top, we now put the 3 moles of oxygen, because that's what we're solving for now. 3 moles of oxygen. And again, if we want to continue, we need to convert from the moles of oxygen gas to grams of oxygen gas. And to do that, we need to use the molar mass of oxygen. This is probably one of the easier molar masses to calculate. Again, we're solving for moles. So mole, it should be 31.98 grams of oxygen. Because 1 oxygen is worth 15.999. 2 oxygen atoms, because it's O2, becomes you add those 2 together, you get 31.98 grams. If you want to round it from 16, round it to 16, you would get 32 grams per mole. So it's not too different. if we follow this process, again, let me try and eliminate the units. Let's see how the units cancel out. Grams of P2O3 cancel out. Moles of P2O3 cancel out. And the moles of oxygen cancel out. So the only unit we're left with are the grams of oxygen. So now if we solve this, it's 100.35 times 1 divided by 109.94 grams times 3 divided by 2 times 31.98. And then the 1 mole divided by 1 mole. But yeah. If you solve all of that out, if you go through that process, you should be getting 43.78 grams of oxygen. I'm going to pick up the computer for a hot second. So those are the final answers for problem 2. And I do expect you to label with your units and the units, which are the mass, the grams of that specific product. So grams of P4, 56.5 grams of P4, and 43.78 grams of O2. Now I want to show you something kind of cool. What happens when you add 56.5, the mass of P4 formed, with 43.78 grams of oxygen formed? If you add that up, you should be getting about 100.28 grams of product. That's really, really close to the initial mass of 100.35 grams of P2O3. So this goes back to the law of conservation of matter. There's like a 0.07 gram discrepancy, but that's very minor. That's probably because we've been rounding. We tend to do a lot of rounding in this class. But ultimately, that won't affect our results too much. The point is the sum of these two products formed is about equal to the initial mass of the reactant. Okay, so I just wanted to share that with you. I hope you find these videos helpful. I might do more in the future, depending on if you like them, if you enjoy them. Just one more thing. This is just grams of P4, just grams of O2. Sometimes I see some people label it grams per mole, but we're no longer using molar mass here. We only use molar mass for the conversion factors. That's gram per mole, but the moles cancel out to find the grams. Okay. Best of luck with everything. Be sure to practice safe driving habits, safe sports team event behavior, show decorum, be respectful, practice safe lab behavior, and be careful when going online. Have a great weekend, gentlemen. Hope you find these videos helpful. If you feel stuck on stoichiometry, let me know. We'll find a way to work with each other. You can come by my office hours. Don't forget, you do have a quiz on this a week from now on stoichiometry and finding molar mass. So be sure to visit my office hours by then. Okay, so thank you very much, boys. Have a wonderful day. Wonderful. and I'll see you sometime soon.